Everyone. Thank you for joining us today for the next edition of the PEG Experts Forum. My name is Michelle Ali Murati, and I'm the Marketing Manager for Tightrope Media Systems. For those of you who are joining us for the PEG Experts Forum for the first time, this is a free webinar series that we offer to folks on topics that we think are relevant to folks in community broadcast, so public access, education, and government broadcasters. We've offered everything from different community media center management platforms to archival options like the Community Media Archive. And today we are presenting on shared storage. So again, thank you for joining us. We have quite a few people registered, so I'm just trying to give them a few more minutes to hop on. It looks like we're gaining more with every second here. So I'll just cover a few housekeeping items to get us started. First of all, we are recording this webinar. So for people who want to hear it again or have coworkers who weren't able to join us today, it will be available later on. And also just for future reference, if you remember something that you want to go back to later on. That's all kept on our YouTube channel. So you can take a look there, and you can also subscribe so that you get all of our future updates on YouTube as well. And also one other housekeeping item is that feel free to ask questions as they come to you. We will address those questions at the end. So we are going to go ahead and go through the full presentation, and then we will have Q&A at the end. We're going to try to keep this presentation down to about 20 minutes. So we won't take the full hour because we want to give you all some time to actually ask your questions and have a little bit of discussion. So just do keep that in mind. And again, feel free, as questions come to you, go ahead and put those in the question box, and we will address those at the end. So first of all, just to give us a little introduction as to why we're interested in covering this topic today, I'm going to toss it over to Daniel Crossan. A lot of you already know, I'm sure, on the call. And then we'll pass it over to Ian to get started with his presentation. So Daniel, I am tossing the screen to you right now.
Thanks, Michelle. And I think everybody can now see my screen. So yeah, I have the Tightrope website open and just showing some of our servers on the Cablecast page, because this year we actually introduced new models for the first time in really almost a decade, actually maybe over a decade since we released the SX servers. And we introduced a new series called the Flex series. And the Flex have two things that give it the Flex name. One is that they're now flexible in terms of the in and out configuration. You can set it to have all of the output, all the BNCs on the server be outputs, playout channels, and none of them be encoders. Or with the Lite or Flex 2, where you have two I/O, you could set it to be one encoder, one decoder, or even both to be encoders if you had a system you wanted to capture two channels on. And then with the Flex 4, you have four I/O that could be three playout channels and one encoder, two playout channels, two encoders. So that's one area in which they're flexible. Another that we've always had, but I guess I can highlight here, is that we play all sorts of file types and resolutions. So you can flexibly go between standard def and high def, 1080p, 720p, 1080i, H.264, MPEG-2, ProRes, all these things you can mix and match between. But then the last thing that we've actually done for the first time is we're actually offering what we call flexible storage. So with the Lite model and the Flex 2 model, they just come with the storage that they have. The Flex Lite has a 4 terabyte media drive, just one of them, no RAID. The Flex 2 offers 10 terabytes of RAID storage. And the Flex 4, which is the flagship model, you can see here now we say that you can get it with 16 terabytes, 32 terabytes, or 0 terabytes. So the first thing is the 16 and the 32 are actually us rounding down. We really give you more like 18 and 36. But the 0 terabytes, we've had folks for a long time who, very large stations who have multiple servers, they want to use all of the storage in one location and not use the storage inside the servers. Or folks who, they're going to plan on getting a 200 terabyte storage system anyway, so why do they want to have it inside the broadcast server? So we just started offering this 0 terabyte configuration, and with that you actually can put a fiber card in the server and then connect it over the network to the storage. And this, this ability for us to officially, formally support network storage, whereas in the past we've always informally supported it, but folks who were capable of supporting it on their own could implement. Now that we're going to formally support it, we thought it was a good time to address the differences between SAN and NAS and all the different elements of shared storage. So, I'm going to pass it over to Ian at this time. Ian, I'm going to hand the screen to you and let you go with the presentation from there.
All right. Hello, everybody. Get started here. So, just wanted to get started. I'm an engineer here at Tightrope Media Systems. I've been here at Tightrope for about 2 years. Before that, I worked for 10 years at a public access station here in the Twin Cities, CTV North Suburbs. I wanted to kind of do this today because I care a lot about building peg stations. It's a lot of fun for me. I even have, a peg station in my home that operates to HD channels all the time. And I think this stuff's interesting, and I want to kind of spread some ideas and things to think about so we can all do this better. Because a lot of us right now probably have something that looks like this somewhere in our facility. We have a shelf full of hard drives that are sitting there when we're trying to figure out, what are some options that we can do to implement a shared storage solution that works for everyone. We kind of have two main kind of concepts that we're dealing with. We have SANs and we have NAS devices. SAN stands for Shared Storage Area Network, and NAS stands for Network Attached Storage. They kind of function in fundamentally different ways. SANs are a shared network of storage, and NAS devices as a file system that's shared over the network. So it's basically a change in where the information is aggregated and distributed out over your network. SANs offer direct block level access to your data, whereas a NAS offers you file level access to your data. Kind of a loose analogy for this is if you kind of think of your money in the bank as your data. When you can have your money in your account, or you can have cash in a safety deposit box. If you want to go look at your money, you can go to the front desk and you can go to a teller, and they will tell you about your money, and you can get a approximation of what's there. Whereas with a SAN type deployment or your safety deposit box, they're provisioning you a bucket of space that you have complete ubiquitous control over, and you can access however you wish. SANs are deployed using kind of two predominant technologies. One is called fiber channel, which is a dedicated type of networking that's just for storage. And there's another one called ISCSI, which is a IP protocol that runs over traditional networks. Whereas NASs use a file sharing protocol like SMB, which is commonly used in Windows, and the Apple filing protocol that's used in Mac OS systems. So at its basic level, a NAS is any server that shares its own storage as files with others over the network. The benefits of a NAS type deployment is you can go to the store, you can buy a small rack-mounted 16 terabyte NAS for a couple $1,000s. They're fairly cheap, they're easy to set up, and they work great most of the time for most applications. Some of the drawbacks that you have with these type of technologies is that file access is always arbitrated by the server. So if there's a lot of people requesting data from this file server, since that file server is also acting as traffic top for this data, the more requests it have, the more it slows down. Even if it's simple as somebody just browsing through some thumbnails or somebody else is watching some videos, you don't really have any granular controls for how that data is being accessed and who gets what priority over what information. The server itself is responsible for enforcing file permissions and file access rights. It means that every time a client device needs information about a file, it has to ask the server for information about that file. The server has to respond. Most of the time, that's not a significant deal, but in media-centric workflows, that can be an issue when you have a folder with 10,000 images. Going out and accessing all of the metadata for those 10,000 images can be time-consuming and resource-intensive on your file server. The other issues with a NAS-type deployment is that files are normally accessed by their entirety or a byte offset. So you can't, if you have a long 2-hour video file and you need 5 minutes out of the center of it, you can't just go ask for the 5 minutes out of the center of the file by directly addressing those blocks of information. You have to access the file in its entirety and then offset where you'd like to start. And that process is a little more resource intensive and can cause some performance bottlenecks in certain deployments. A SAN, on the other hand, in its simplest form, is an architecture to attach remote storage to make it appear and function as though it was locally attached to your computer. So when you plug in a USB hard drive to your machine, it shows up a little differently in your computer than when you access a network share. And your computer fundamentally communicates with it differently. Because it has direct block level access, it can directly communicate with all that information anywhere on the disk without having another system kind of acting as traffic cop slowing it down. Like I mentioned before, SANs are kind of deployed through two different types of architecture. One is fiber channel and ISCSI. Fiber channel uses dedicated fiber channel switching hardware. So it uses a switch. It looks like an Ethernet switch. It costs twice as much as an Ethernet switch, but it's not an Ethernet switch. It's dedicated just for storage. One of the advantages with fiber channel is that you can notch out guaranteed segments of bandwidth for each of your systems. So you can very easily control with a high level of granularity how much speed every single device in your switching fabric gets. So you can guarantee that you're able to get your encodes written to disk and your files to play out to air without any storage contention issues. And fiber channel's been around for a long time and is available in speeds anywhere between 1 and 32 gigabits. One of the advantages of ISCSI is that it is a protocol that kind of sits on top of IP, or a lot of the Ethernet networks that we already have. It's generally cheaper to integrate into existing infrastructure because you're able to reutilize some of the Ethernet switching equipment that you already have. And then it's basically, because it's based on IP and it's used over Ethernet, it runs at roughly the same speeds as different Ethernet networks do. ISCSI, like I said, is nothing but a standard for interconnecting storage arrays and hosts. So you have boxes of hard drives and you have machines, and it uses the ISCSI protocol to connect to them over the network as if it was basically attached like with a USB or firewire cable, except you're doing that over your network. Your computer sees it the same way as it would a locally attached computer, but it doesn't require any specific special cabling like a fiber channel network does. However, it is recommended for peak performance that ISCSI storage networks be run separately from your regular data network. Some of the disadvantages that ISCSI has over fiber channel is it has a little bit more latency because of the fact that it's running on IP. You have to, when you're encapsulating your storage information, you have to put your IP addressing information into all those packets, so that does create a very small amount of latency as compared to other storage topologies. This can be relevant in database type applications where you have very, very quick read-write operations, and in a ISCSI deployment, you will see slightly higher, more latency than you would with a similar fiber channel deployment. And if you don't segment ISCSI from your same LAN network, the transactions for other people browsing the internet can also slow down your storage performance. Fiber channel is available in multiple types of topologies. So with Ethernet, you typically have what's called an extended star topology, where everything plugs into switches and you have like hubs and spokes, whereas fiber channel is capable of being deployed in a couple other ways. You can have a direct point-to-point topology where you have basically one device directly connected to another. You have a switching fabric, which is similar to Ethernet networks that we deploy today with different switches, but you also have the capability of what's called an arbitrated loop. So you can daisy chain your storage together or your playback devices together and form a dual redundant loop between them, so that if any device fails in between, the data can flow the other way and you can maintain your connectivity. And then with a SAN, that kind of solves the issue of connecting to your storage. But then there's kind of another piece that sits on top of that, which is called a distributed network, networked file system, which is essentially kind of the secret sauce to making it all work. So everybody can view and share the same data concurrently. So at its basic level, a distributed network file system allows a system to allow multiple hosts to access the same block level data concurrently. So it's essentially another person, or a way to allow more than one person to have access to our safety deposit box at the same time. Distributed network file systems basically provide a separation of your actual data and your data's metadata through metadata controllers. It sounds kind of repetitious, but on a hard drive, typically you have your data, and then there's space that's reserved for the indexing information or the table of contents for that data, or the metadata. With a network file system, you normally separate that out so that the data itself is stored on your storage array, and then the metadata for your volume is stored, handled, and aggregated through your metadata controllers, which are basically the traffic cops for who has access to what on your SAN. With a distributed network file system, the permissions are typically enforced at the volume level, so you can easily grant access to multiple people to a whole storage container or volume. And file locking is also controlled by the metadata controller. So it's always keeping track of who's reading and writing what where, so that you don't have two people trying to write to the file at the same time. And it also updates other devices when a file is done being written. So if you have a show that's being encoded and it's done, as soon as that file is done being written, the other devices are instantaneously able to see that the presence of that file without having to re-request its status. All connected devices have access to the same storage at the same speed. In a fiber channel type deployment, only the data goes over the fiber channel network. All of the metadata and requests go over your traditional Ethernet network, reserving that full fiber channel speed just for your data. Another thing that distributed network file systems allow for is the support for nearline files. In a situation where you have a tape archive or a tape library, tape libraries are great, but one of the issues they have is they're rather slow. So if you need to take a file online and offline, it can take 15 or 20 minutes to bring that file off of tape and back onto your nearline storage. Excuse me. And with some of these network file systems, you have the ability to virtually represent your entire media library in one place, regardless of whether it's on active hard drive based storage or on a tape archive. And then when you request that file, the system will automatically pull it from tape and make it available before it's needed. When you deploy a SAN, you will always have some form of metadata controller. Normally, you will have two for redundancy and allowing for multipathing across your network. This is accomplished by using a virtual IP address between the two machines, and then they communicate to each other with a heartbeat, so they can automatically fail over from one to the other, depending on which one is working. With a SAN, you can kind of have two primary workflows. You can have a kind of a SAN-only workflow where all of your clients, regardless of operating system, are connected to your primary storage and your metadata controller. And then you also have the option of combining a hybrid SAN and NAS workflow. And one of the advantages to this is that you can re-export your SAN storage through a NAS gateway, so that lower cost clients can still access your storage using traditional file sharing protocols, where your editors, your playback system, and your high performance devices have dedicated guaranteed access to that same data by having a direct connection. So you kind of get, with a hybrid workflow, you kind of get the benefits of the best of both worlds. These slides were taken from a presentation from Scale Logic in Bloomington, Minnesota. They developed the HyperFS file system, which I've displayed here. There are multiple others, such as ADIC StoreNext, EditShare, that perform similar functions. But today I just kind of wanted to present some ideas and concepts that you guys will hopefully be coming across in your access facility soon. Thank you very much.
All right. Thank you, Ian. I actually don't, we still have a lot of people here on the call, but I don't see any questions. So I'll make a call right now to folks to say if you have some questions, or if there's something that you want us to go back to, a slide that you want to see again?
I have a basic question for Ian. SANs tend to cost more than a NAS. Is there a general sense of how much, like a factor of 2 or 1.5 or 3, or is it just range so much that you can't really say that a SAN is 50% more or 100% more for similar storage?
So one of the advantages to a NAS is that you have a almost zero per client cost, because you're using the built-in file sharing stuff in Windows or the Mac OS. With a SAN, you do have a much higher cost per device that you connect, because each device is going to need either a fiber channel card or possibly an iSCSI HBA. Those cards are roughly $1,000 a piece, plus or minus a few hundred, depending on options. You also have, the distributed network file system, which licensing costs on that can run anywhere between $100 and $1,000 per connected client. So that's kind of, so it can be upwards of $2,000 per machine that you wish to connect to your SAN.
Got it.
On top of the storage itself.
Yeah. So whereas with a NAS, you only have to take into account the storage, because you're just going to use your network and the rest of your existing hardware. With a SAN, you have to take into account the storage plus the equipment you're going to add to each, and licensing you're going to add to each endpoint.
Yeah.
Okay.
So we did have a question here from James asking, are there any hybrid systems?
So there's the one of the products I mentioned is the HyperFS, which is a file system from ScaleLogic. They make a Genesis NX and a Synergy file system that both support fiber channel and iSCSI connectivity options, plus also have the capability of resharing their data out as a NAS share too. I know there's also products from Studio Network Solutions, Edit Share, that also have hybrid SAN NAS solutions available.
Great. And then we have a question from Randall asking, he says he has 2 Flex servers with 16 terabyte internal storage and wants to know if he can connect a SAN Facilis with a fiber channel card to his existing Flex servers.
Yes. Yes, you can.
Very
yeah, just because if you ordered a Flex server with onboard storage and you decide later that you want to connect it to your SAN, there's nothing preventing you from doing that. The slot that's available for the fiber channel card and the zero storage option is also in the other 2 units.
Great. So Randall, I hope that helps you with your question there. The next one is from David. He wants to know, how many editing systems can you run concurrently on a SAN? We're working with Premiere, largest projects being 3 tracks of 100 megabytes per second.
So your limitations are going to be based off, so if you're doing 3 tracks of ProRes, each ProRes stream is roughly 220 megabits per second. So you're going to be slightly over a gigabit per machine. You can add up, basically it's going to be your total amount of bandwidth for all the streams of video that you're using. And then you basically have to spread it across your storage to make sure that your storage and your switching fabric can support the number of clients that you need. In theory, you can architect the system in such a way that you can expand it to hundreds of thousands of connected clients. But there is a significant, there is an exponential cost as you add more, but there really isn't necessarily a hard limit to the technology itself. It just kind of depends on how you architect it.
I was still on mute there. All right, so the next question is from Patrick asking, can I integrate my old SX server into a SAN with the correct IO card?
That's something that we depending on the age of the SX machine itself, that's something that's definitely possible. But it's not something that we formally support at this moment. But as long as it's a somewhat more recent SX, it shouldn't be a problem.
Okay, great. And then I have a question, more product-related question from John. Daniel, maybe you know the answer on this one. What is the current status of upgrade discounts for existing SX owners?
Sure. So we offer a trade-in now where we'll give 10% off of the price, and that's off of the list price before it goes to the dealer, and then the dealer gets, a discount that they can pass additional percentage on down to the customer. But if somebody has an older server, they want to upgrade, and they have, an existing SX server, or really any of our equipment that they could be quote unquote trading in, even if we don't want the thing sent to us because it's so old, we'll give the 10%. And if anybody has questions about that, they should just reach right out to me directly. I'll talk them through what we could do there and how.
Great. And then we had a follow-up of what about a 10-year-old VS server? I'm not sure about that
We're
one.
shocked when people keep 10-year-old systems running. We actually, I think, took a 12-year-old system out of somebody's place recently. I'll give you the trade-in on a 10-year-old system. You just get to keep it and send us the hard drives because we don't know what we do with a 10-year-old one on our shelf.
Great. And another question from Brian. We have an edit lab with 15 iMacs that our members use to edit their projects. If we wanted to provide some kind of centralized storage for that, what kind of solution would you recommend?
Well, for a lab with iMacs, you have kind of a couple of different options. There's it depends on kind of how much you want to invest in it. Kind of will dictate how much shared storage you want to provide. In general, with an iMac, you can connect it up to any storage network the same as most other machines. There are Thunderbolt fiber channel adapters available. There are Thunderbolt 10 gigabit Ethernet adapters available for iSCSI. Studio Network Solutions, Edit, Share, Scale Logic, all are available for Mac OS and Windows. So you could use all of those SAN topologies with that type of deployment.
I hope that addresses your question, Brian. It looks like I don't have anything new coming in, so we'll give folks another minute here.
Actually, I see a couple.
There's a couple more coming in. We have David. I'm sorry?
No, I think there were a couple older ones. There was a question about, can the Flex servers connect to a NAS? Did you answer that?
The Flex servers can connect to a NAS, but because of the issues where we don't have any controls over performance and access to that storage, it's something that, if set up right, can be done, but it's not something that we can directly support doing for playback storage. But if you can make sure that you have the bandwidth concerns met, it's something that does work, but it is not something that we can directly support because we don't have control over the performance characteristics the same way we do with a real SAN.
And that's addressing specifically the way a Tightrope server would behave with a NAS, right? Or how we would address that if someone were to use it on our platform. We can't speak to folks who might be using other platforms.
Well, you'd have similar. I mean, the support issue is in the fact that because you can have a very large variety of different NAS deployments across different networks with different configurations, there aren't very many tools and resources to ensure and guarantee dedicated access and bandwidth to the storage. So it comes down to it's not a way we can reliably guarantee that it will work. It's not that it doesn't, and it doesn't do it well most of the time, but it's not a thing that we can repeatedly support well.
Okay.
So there was another one that I saw earlier on. It asked if do we see the Flex technology moving into the Zplay platform? I haven't heard any discussion of that. Ian, have you do you have any different knowledge? As far as I know, there are no plans, but
Um, we uh, there are there are plans to at a certain point utilize the similar I/O architecture from the Flex 4 in the Z-Play, but we have not decided when that will necessarily be.
okay. Thanks.
We have a couple more here. I'm just trying to get caught up. We have a question from David. When building a system, how high would you recommend going with transfer speeds to future-proof against 4K slash higher bitrate video?
I would probably figure out what the the most demanding format you're going to use is, and then add 2 more streams of that format than you think you're going to need. So if you are doing a lot of 4K video, just add 2 more streams of that video on top, and that'll give you some breathing room in order to grow. There's always things that can change in technology. If we start doing, 4K and 3D again, we're going to all of a sudden double our data rates again. So there's things that can change with technology that can dramatically increase your storage footprint. But it's just as kind of a safe linear progression, I'd say, pick what the highest bitrate format you're going to use is, and then just add 2 more streams on top of however many you think you're going to need.
And then the next question is from John. Where can we purchase the fiber adapter cards for old SX2 HD servers?
So that is going to be what cards you use is going to be a little more dependent on the type of SAN solution that you're implementing. So for the older SX machines, that's going to, there are open slots in those, and there's going to be kind of a we have to determine, what's compatible with your particular SAN, and also what's going to fit in the slot in the SX. So it's not as much as us directly supporting, a selection of cards. It's more we're providing a slot that if your SAN supports using that, we'll work with it.
Okay. We have another question from Larry. How do we get help designing a specific solution for our application?
Steve, I got a question for you.
Let's see. So really, I think you would need to look to the integrator that you use in order to get that done. It's nothing that we support directly. And if you need a reference for an integrator that could help you with that, just send an email to sales@trms.com.
Okay. We also have a question from Patrick. Can metadata controllers be virtual machines?
Metadata controllers can be virtual machines. They can definitely be virtual machines. One of the issues that you can run into is if you are virtualizing the metadata controllers that are integral for accessing your storage environment that also hosts your VMs, you can run into some chicken and the egg scenarios that can be a little scary when dealing with different recovery and fault tolerance scenarios, but there isn't anything precluding you from doing that. But architecturally and for redundancy reasons, you may choose to keep those as separate physical pieces of hardware.
And we have another question from Brian. Do you have an opinion on Drobos ISCSI Project products?
So Drobos ISCSI Project, I mean, the price point that they operate at is great for generic storage. They just don't have the performance needed for real-time playout or real-time editing from multiple people. With the way that their RAID system works, it's great for its low manageability costs and its lower price point, but you're not going to get the same performance you're going to get out of a real SAN.
And then a question from Terry. Would you use the same SAN for an SX file storage and edit stations? So for instance, would you need two separate SAN solutions, one for an editing computer and one for playback?
Nope, absolutely not. And that's the beauty of a SAN, is that because you have the ability to control and guarantee bandwidth between performance, you can design your SAN in such a way that you will guarantee your playback servers the bandwidth they need to play the content on the channel without impeding your editors from editing the video and not having your editors' work affecting your playback system. So because you have some of those, a lot more of those controls in a SAN, you can deploy all of those things on the same collection of hardware.
So that was helpful, Terry. And I'm coming back to this one now because I don't see any new questions coming in, but looks like Danielle had a somewhat adjacent question asking, they currently have a hardware solution for storing files, but are using an Excel spreadsheet, institutional memory, and a paper log to record shoots. Any software suggestions for searchable file library for non-editors?
Media asset management platforms, or MAMs, are not really my forte. So I wouldn't really be able to comment or give a solid recommendation on that.
But that would be the search term then?
Yep, yep, that'd be a media asset management platform.
Okay. And let's see, we have a question from Patrick asking if we can talk about tape backups, like tape archive libraries.
Tape library compatibility is dependent on the particular SAN file system that you go with. There's lots of different tape libraries out there. It's basically the tape library is used in order to get a higher data storage density when you don't, for archival use, when you don't necessarily need direct recallability. So when you have, programs that are no longer current, you can nearline their storage so that they are they're stored in lower cost storage over longer periods of time than necessarily a hard drive. Particular compatibility with different library systems is going to be dependent on the particular SAN architecture that you go with, and also what type of media management applications that you're using.
Okay. One more from Chris. Does Tightrope plan to offer any SAN solutions? That's for Steve. But I have a guess.
Yeah, I can say that we don't really have anything in the pipeline for that. It's if that's something that you'd like to see, actually for that or anything else that you'd like to see, you could send an email to features@trms.com, and we'll make note of it. But yeah, currently there are no plans.
And a question from Brian. Follow up on the iMac Edit Labs question. Would an ISCSI solution instead of Fiber Channel be adequate for our members' video editing needs?
Most likely, yes. But there's a little more to it than just the protocol selection. You have to make sure that you have enough storage bandwidth to your storage array going through switch networks so that everybody can be editing at the same time. But as long as all of those requirements are met, ISCSI is a perfectly acceptable solution for that.
Okay. And then I'll go back to this one now since I don't see new questions coming in. We had somebody ask to see your home access center that I think you showed a photo earlier that they wanted to look at earlier on in your presentation.
Yep.
They want to check out your rack.
It's a bad picture of it I just took this morning, but I can display it again here. So going up from the bottom, there's a 2200 VA APC UPS. Above that, there's a dual processor 12-core Xeon machine running VMware for my virtual machines. Above that is a 7-channel surround sound receiver, a display processor for a secondary projector, a routing appliance. There's a 48-port switch, 16 terabyte NAS appliance. There's above that a H.264 High Vision Makito encoder, a 16-port Atlas and KVM, a Tightrope SXLE HD video server, 2 Mac Minis racked up, and then a Blu-ray player and power distribution. There are other machines not pictured, including a Harris DVM 950 waveform vector scope and a series of displays and test source generators.
And then we also have our mascot Pippin photo.
Yep.
And knowing Ian, he probably bought all of it for $237 on eBay.
I didn't spend that much on that. Yeah,
More or less.
I didn't pay retail on any of that. I'll tell you that.
We do have a couple more questions that have come in. Patrick wants to know, can iSCSI and Fiber Channel be mixed in the same system?
Yes, they can. Yes, they can. So there are Ethernet switches that support fiber channel over Ethernet, and there are also fiber channel to iSCSI bridges. So that is functionality that you can integrate. You can either do it with bridges that kind of bridge the two networks together, or you can get higher end Ethernet switches that support the tunneling of fiber channel data over Ethernet networks.
All right. I don't see any new questions coming in, so we'll give folks another 30 seconds or so here to type things in if they think of them. But thank you all for joining us today. I want to just reiterate a couple things I mentioned at the beginning for those of you who might have hopped on a little late. This is a series, this PEG Experts Forum, so we have offered several in the past. We continue to plan new ones for the future. And if you have suggestions on topics that you'd like us to cover in the forum, I'm going to go ahead and put my email here in the chat for you guys to send suggestions to, because we're always curious, about how we can keep you all informed about what you're facing in the industry. So again, thank you for joining us today. And if anybody wants to go back and reference this presentation again or share it with a coworker, it will be available as a recording. We'll be putting that up on our YouTube channel, and I'll be sharing that out on our social media on Twitter and Facebook. So if you don't already follow us there, you can do that, and that's a good way to stay up to date on this forum and then also other news from Tightrope. So thanks again to our presenter, Ian, and thanks to Daniel and Steve for joining us as well and answering some questions and talking about what's new at Tightrope. And so I don't see any more questions coming in. We'll go ahead and say thank you all and enjoy the rest of your afternoon.
Bye, everybody.
Yep. Thank you for attending.